the rest of this week looks like. If you want to come see me, this afternoon, tomorrow afternoon, and then there's our exam Wednesday morning at 8 o'clock in the morning. I don't write the exam schedule. I've never created it. I have not managed a semester yet without an 8 a.m. exam in 23 years. So we deal with it.
Why do they even make this like a special exam schedule?
So that we can make sure that no one has to sit 2 exams at the same time. Because the exam is in 2 hours.
Wouldn't be taking 2 classes. Because the exam's 2 hours.
Exams are 2 hours. Yep, that's the whole reason. So, what questions do you have for me about the final? 22. Questions you have seen before from other pieces of the work you've done, potentially with numbers changes, and that's about it. True, false, yes, no, 3, 107. Yeah, keep going.
Any ratio to a review as opposed to new material?
The exam is almost equally split in quarters. When I counted, it's 31 points from the first exam, 25 points from the second exam, 34 points from the third, and 30 points on new material. Yep. Exactly like all the previous exams. You are entitled to every formula sheet you have already used, the ones that have my initials on them, and a new one. Same rules apply. One side, 1 8.5 by 11 sheet of paper in inches. And make sure your name's on the back or somewhere on it so I can see it, and I'll initial it, and then we'll go on about our business. More questions.
Do you believe if we could get 100 on the last 3 exams, like if we did all 3 exams and then did the new material, we'd be okay for the new?
I guarantee you that's a good way to tack this, is to go back and review what you struggled with the most on the previous exams, look at the exam reviews, and then look at the final review. And I think that's really your best place. If I haven't tested you on it already, it would kind of be unfair for me to pull it out of my ass and say, here, I want you to do this one you've never seen before. So I try not to do that.
I'm sure it wasn't like something in the chapter that we reviewed, but we didn't test.
If there's something in there that's important enough for me to make sure you know it for the final exam, wouldn't I have wanted to make sure you know it earlier?
I would hope so.
So would I. The Boolean matrix stuff? No. I like that a lot. There are easier ways to do that stuff. You're welcome to do it that way, but you don't have to.
What's the #1 chapter that everybody messes up on the final?
Chapter 5, proof by induction. Because y'all effed it up royally before, didn't you? A lot of it is memory. What do you remember well? Because I know people will get to something, they'll be like, in chapter 2 or in chapter 1 on sets or on truth tables or something, it's like, I know I've seen this before. What the hell am I supposed to do with it? If you were fluent in base changing before, you don't have to go back and look at it a lot. If it was something you struggled with, you should look at it. It's always a matter of what do you think is going to be your weakest piece. But I know you will have seen all of these questions somewhere before. Yes.
What was that average?
I haven't the foggiest idea. I'm not allowed to show you other people's grades. Give me a second. Spring 2024 grades. $73. I got rid of the names.
Out of the last chapters that we have not been tested on, what percentages are there from each chapter?
I don't have that in front of me.
Which one
But
do
if
you
I'm-
mess up on?
Again, it's what do you find to be the most familiar versus the most psychotic? Well, again, I don't have I don't have a by question breakdown for the final. I didn't do item analysis on that one. I do have the overarching grade distribution we were just looking at. And I can say it's 6 sections, right? 7-1, 8-1, 8-2, 9-1, 9-3, 9-5. I think it's a question from each. I am not out to F you all over. It is not, there is nothing in this world that I will say can bring me less joy than going, now that guy gets an F. That's a horrible feeling. Because it means that there's big communication error here, and we've been doing this for 4 months. We should be better at this. So I want you all to be successful. I can't make you successful. Yes, sir. Yes.
Do most people feel like they have enough time to review the questions afterward on this one?
Most of the time, people don't stay the entire 2 hours. So I think that might help better. I've had a couple of people stay through the very end, scribbling furiously the whole time. But I think most people do get the chance to sit down and go back and look through the questions afterwards.
That's one of the question count, is that include the bonus or?
Yes. I believe. It might not. Yes. Which chapters? It isn't. It isn't. More. I got 24 more minutes with your name on it. Yes, sir.
We go through the problem on exam grade multiplied with the first one.
Sure. So the problem asks you to show that a particular number is a multiplicative inverse, right? Good. And now I'm going to need a show that
7.
47 is a multiplicative inverse
23 mod 60.
Okay, so A is a multiplicative inverse of B. Means that A cancels B mod 60. So A is a multiplicative inverse of B mod M if AB is congruent to 1 mod M. So all I really need to do is multiply 47 by 23. What do you get? Right? That is equal to some number of 60s plus something. What's the quotient remainder here? but 18 times 60 is 1080. The remainder is 1. 47 times 23 is congruent to 1 mod 60. It's an inverse. Now, what do I do with that inverse? I use that inverse to solve a problem. Look at what part B says. Part B of this problem says, solve Now, if I were solving this without the mod, I would simply divide by 23. But I'm working in the mod universe, so I can't divide. I multiply by the inverse. I know the inverse is 47. So 47 times 23x is 47 times 16. But since I'm working mod 60, on the left, I get 1. So on the right is my answer. What's 47 times 16? So I now need to do that mod 60. 60 goes into 752. That should be 720 is a multiple of 60. So that's 3. What's my quotient? 32 times 6. Well, my 32 is my remainder. Since 752, 72 divided by 6 is 12. There's my remainder. The whole purpose for having a multiplicative inverse is to get around my requirement to divide. This is how you do the RSA decrypting. Useless, never gonna see it anywhere. Only you do it in the powers, and then you're doing a bunch of modular exponentiation at the same time. More questions? Yes, sir. Sure. Grab the textbook and we'll find one. Jordan, A through G, pick one. F. AN equals 4AN minus 2. Page 551, number 3, F. AN equals 4AN minus 2. A0 is 0, A1 is 4. Okay. This is a degree 2, a depth 2 homogeneous relation. So I'm going to solve with the quadratic. R squared equals 4. I take 1 off the power for each change in the exponent. Took 2 off here, so I take 2 off there. It's just R squared equals 4. What's R? Or, aha. So that means that AN is some number times 2 to the n plus some other number times negative 2 to the n. I used alphas. We can use any letter you want. Might as well use capital A and capital B. In order to solve for A and B, I use my initial conditions that I was given. A0 means n is 0. A0 is 0, so that's A times 2 to the 0 plus B times negative 2 to the 0. But raising something to the 0 power gives you 1. So that means A plus B is 0. Now I do the other initial condition, that's A1. So that's A times 2 to the first, B times negative 2 to the first. But raising sum to the first power gives you that number. So I get 2A minus 2B is 4. And now you have your choice on how to solve this. You could use it, elimination by addition. You could use a substitution. You could use all sorts of methods. If I take that first equation, I can write B is minus A. I can then put that in here. And I get 2A minus 2 times minus A is 4. And that makes minus to minus is plus. 4A is 4. So A is 1. Put that back here. And I get B is minus 1. And so now I have AN is 1 times 2 to the n plus negative 1 times negative 2 to the n. Every time I want to solve a recurrence relation, I start by solving the quadratic equation or cubic equation or whatever polynomial equation that goes with the recurrence. That's how I got these roots. And I always write my solution as a linear combination of those roots.
What final grade you round result?
All grades are computed in Excel and rounded to the nearest whole number. I love being able to quote the syllabus.
Which problem should we use a calculator for, and where can we get this stuff to make sure that we know how to use a calculator for it? So you can put in your calculator, you can find the greatest common divisor or the
Greatest common. So if you want to use your calculator for something and I have not told you a method by which to do the thing, use the calculator. If I say I want to see you do it this way, I want to see it. Where do you find the how-to on the calculator? I would recommend the Texas Instruments website, education.ti.com, has all the entire manual for whatever graphing calculator you've got. If you don't have a TI, you've got a Casio or a Hewlett-Packard, same thing. The manuals exist on our on the web. Just download the manual, you can figure out exactly what it is you want to do on your calculator.
Is there any problems that you could advise using the calculator for just for saving time?
In order for me to think that this exam is appropriate, I did everything as longhand as I could and said that's a sufficient amount of time. So I did it very little directly on my calculator. I will say that I recommend doing all of the arithmetic you can on your calculator. So something like, I don't know, base conversions, where you're repeatedly dividing for quotient remainder stuff like we were just doing. I would do all of that on the calculator. There really isn't a lot else I can do strictly on the calculator that still answers the questions I want answered. Does that make sense? More questions.
Is there anything you would recommend putting on the last cheat sheet, I guess, or formula sheets? Is there any very important formulas you think should be on that last formula sheet, or something that you think that you've seen a lot of students miss on the formula sheet?
Well, Jordan just asked about these recurrence relations. I would put something like the general form that we were looking at. I'm not sure I would write out the whole big version that I gave at the very end of class, but maybe writing, you know, that or that. Those are the two versions we used the most. I would make sure those are on there. If you want to go back to that Boolean matrix thing and write down the definition of what it is from chapter 2, You can, I'm not sure that's helpful. But really, formulaically, this last set of chapters was fairly light. Oh, write down the definitions, right? What's it mean to be reflexive and symmetric and anti-symmetric and transitive? Got a chance to write down definitions, write down definitions. Probability. I would write down the formulas for the probability fashion, that the probability of an event is the number of things in that event divided by the number of things in my sample space. Make sure you, again, write down the definitions of what these pieces mean. The formula for the intersection and the union, the ands and ors for probability. Again, those are probably worthwhile formulaically. A lot of this chapter was procedural. And so having definitions in front of you may or may not prompt you to remember the procedures. I don't know. I tend to think that they do, but I'm biased. I will say the same thing to you I said in the Calc 3 class this morning. I've been doing this for 30 years. You've been doing this not even 30 weeks. There's a lot of difference there. And it's not obvious. Stuff is not easy, trivial, by any stretch of the imagination. Engaging with the struggle, finding the places where you're like, oh, I don't get this yet, is both mentally and physically difficult. Your goal is to do the best you can on this exam. And that's enough. Hopefully, the best you can is sufficient. What are the questions you have for me? Oh, I didn't even get to do it. Who's got a good loud? Well, I'm going to read this for me.
Everything I say will be on the exam.
What are the questions? There you go. What else do you want?
Is that gonna be on the exam?
Did I say it or did you? That's the bonus question. What was the third word of the first class? Yes, sir. If you'll read it to me, I can do it because I don't have the final exam review in front of me. So what's 19? All right, well then let me pull up the review sheet from over here somewhere. Desktop this semester. Exams, final exam review. 19. Okay, consider the relationships R1, x, y, such that x plus y is greater than 10. R2, x, y, such that y divides x. R3, x, y, such that greatest common divisor is equal to 1. And R4, x and y have the same prime divisors. Okay. Reflexive, symmetric, anti-symmetric, transitive. So, a relation is reflexive if x is related to itself for all x. Pick a number. 7 plus 7 bigger than 10? Pick another one. Can you pick one for which that equation is false? Sure, 1. 1 plus 1 is not bigger than 10. That relation is not reflexive. How about this one? X and Y are related if Y divides X. Does a number divide itself? So Y is going to divide Y, or X is going to divide, that's reflexive. Is the greatest common divisor of X and Y equal to 1? The greatest common divisor of a number and itself equal to 1. No, the greatest common divisor of a number and itself is that number. The greatest common divisor of 5 and 5 is 5. It's not reflexive. X and Y have the same prime divisors. Does X have the same prime divisors as X? So, not reflexive, reflexive, not reflexive, reflexive. But I have to go through the argument for each one. Symmetry. If X plus Y is bigger than 10, is Y plus X bigger than 10? Yes. If Y divides X, does X divide Y? No. 2 divides 4, but 4 doesn't divide 2. If the greatest common divisor of X and Y is 1, is the greatest common divisor of Y and X 1? Yes. So, symmetric, anti-symmetric, symmetric, not symmetric, symmetric, I haven't done this one yet. If X and Y have the same prime divisors, do Y and X have the same prime? Yeah, okay, that one works. Symmetric. Anti-symmetry. I gave the game away. Why is this one anti-symmetric?
Yeah.
I want X to divide Y and I want Y to divide X, right? I need to go back and look at something. What sets of numbers are we working on? We're working on the set of positive integers. If X divides Y and Y divides X, that means the only thing they can be multiplied by is a 1. They have to be the same number. So yes, that one is anti-symmetric. On the other hand, all 3 of the others were already symmetric. So I can't claim anti-symmetry out of them. Transitive. Transitive is a little harder. If X plus Y is bigger than 10 and Y plus Z is bigger than 10, do X and Z have to be bigger than 10 when I add them? No. 1 and 10, 10 and 2, but 1 and 2 certainly don't add up to be bigger than 10. Division. If Y divides X and Z divides Y, notice the order. X is related to Y, Y is related to Z. Division goes the other way. If Y divides X and Z divides Y, does Z divide X? That's what transitivity is asking me there. And that one is a yes. We can write out the formal definition of division, right? X is equal to Y times something, but Y is equal to Z times something. So X is equal to Z times something times something. Okay, that works. Greatest common divisor is 1. The greatest common divisor of X and Y is 1. Greatest common divisor of Y and Z is 1. Greatest common divisor of X and Z 1. Why not, Santino? Well, if you can't explain it, we can find an example. Because if it's not true, I should be able to find a counterexample.
5 and 6. And
Okay.
then that would be your X and Y, and then 6 and 3.
But then the greatest common divisor of 5 and 3 is 1. Greatest common divisor of 6 and 3 is not.
6 and 5 and 3. Then you get 6 and 3, which the greatest common divisor is 3.
Bingo. So the greatest common divisor of 6 and 5 is 1. Greatest common divisor of 5 and 3 is 1. Greatest common divisor of 6 and 3 isn't. I got to make sure I put them in the right order. Same prime divisors. If X and Y have the same prime divisors, and Y and Z have the same prime divisors, do X and Z have the same prime divisors? The word the same here carries that through. If P divides X and Y, and P also divides Y and Z, then P divides X and Z. Jordan, better? I want you to write out all of those argument bits. So when you go to answer one of these questions, paragraph of words, or a specific counterexample. I don't think this works. Here's why. If I had said in this question that we are using not just positive integers, but all integers, then Y divides X and X divides Y wouldn't be antisymmetric. Because 2 divides -2. -2 divides 2, but they're not the same number. Because I restricted myself to positive integers, that one actually is antisymmetric. Yes, sir.
For that example, like that was anti-symmetric, but the other ones weren't, like, to explain, is it okay just saying that because we're in it was symmetric, or is that not?
Right, because antisymmetric and symmetric really aren't exact opposites like that. I think it would be easier to go the other way. If X plus Y is bigger than 10, then Y plus X is bigger than 10, right? How does that imply that X and Y are the same number? It doesn't. And I can give you an example. 8 and 3, 3 and 8, but 3 and 8 are different numbers, aren't they? So I can give an example for it being not antisymmetric. Ladies and gentlemen, congratulations. You've made it all the way to everything except the exam. So if you have questions this afternoon or tomorrow afternoon, my goal is to have your homework graded and available to you by the time this office hour starts. If you want your homework, come get it from me tomorrow afternoon. Otherwise, I'll give it back to you at the exam in here at 8 o'clock on Wednesday. See you all then.